I do want to remind everybody that there's other sessions going on today, so please, check out the conference website for the agenda. And at this point, Gene, I will turn it over to you and Alicia to introduce yourselves.
All right, great. So welcome everyone. I'm Gene Garcia. I'm a principal architect with the education analytics team. And Alicia?
Hi, good afternoon. My name is Alicia Moniz. I'm a data and AI specialist here at Microsoft, and I support the education community in the South Central.
Great. Okay, so let's jump in. This portion of the discussion, I'm going to talk about the modern data warehousing and analytics in education as it centers around the lakehouse architecture, and then I'll hand it off to Alicia midway through. So let's jump right in. The first slide I want to address is this one that talks at a high level about the analytics journey. And I really like this slide. It allows for a lot of discussion with customers and partners around the importance of getting good at BI before you can hope to progress on to diagnostic and predictive analytics. So it's often the case that there are deep ambitions that customers have or partners have around prescriptive analytics, right? But it's also often the case that either there's not sufficient investment already on the more descriptive side, or else the investment is in an area or a tech stack that doesn't lend itself to more of these complex forms of analytics. So at a high level, though, I like how this slide demonstrates the progression, right, of trying to get your hindsight fully capable and then get to a place where you're deriving insights and being able to explain why things are happening. And then finally, deriving that foresight, being able to predict and prescribe based off of your data. So this is what we're talking about at a high level, nothing new there. Let's talk a little bit about the tech that allows for this journey. So if we think a little bit about the evolution of data warehousing, a good starting place to have the discussion is around how there was a time when data was all in databases, siloed databases, and everything's considered transactional data, and everything's in a relational kind of structure. And then on-prem, right? So there's some real challenges there. And going from there, the next stage is one that recognizes analytical data as distinct from transactional data, and the need to have schemas that support the nature of those data, as well as adopting cloud technologies that allow you to scale more effectively and leverage cutting-edge tech more effectively. So that's maybe a second stage in this evolution. And what we're talking about today in this presentation is more this lakehouse architecture, which takes it to the next level, largely by allowing you to decouple your compute from your storage. So this is huge because now with the lakehouse approach, you're able to work with a huge volume of data in a blob storage service that utilizes open source standards, data standards, and thereby liberate your data in the sense that you can bring whatever compute to that data that you might need. So this really opens up a world of opportunities, not least of which is better leveraging of advanced data services, which are often serverless. So giving you a lot of cost advantage. So here at this lakehouse level, you get the best of both worlds between a data lake approach and a data warehouse approach, in the sense that you have this super flexible storage that is very low cost. So you can throw in your structured, semi-structured, unstructured data and not be overly concerned about cost of storage. Yes, you still have to watch the cost of storage, but you don't have to optimize so strongly for cost of storage. You can choose rather to optimize for clarity and for your team's time. You have that advantage, and then you have the advantage of using these open standards rather than a proprietary storage format, allowing you then to bring in all these other types of compute that can be serverless. But you're also able to run queries leveraging the skill set that your team already has. So that's how I like to define at a high level the evolution that we're talking about. We'll talk more about the details of what that lakehouse architecture looks like here shortly. Well, actually, on this next slide, we'll talk a little bit about that. So I'm not going to go too deep into the Azure tech stack, but it's worth mentioning, at least at a high level, how Microsoft sees this playing out and the investments being made across industries to address this market. So Azure Synapse, initially this brand referred to the evolution of SQL data warehouse. And so Synapse was considered, the next level of SQL data warehouse. But this brand now has grown to encompass a large number of technologies around analytics. And so it's really providing this unified experience that's built primarily on the data lake storage as a starting place, but also using dedicated SQL pool as an optimization or as an advanced service. So what this diagram is depicting is the age-old challenge of you've got siloed data on the left-hand side. You want to effectively bring it into one place and have your data centralized so that you can apply, the powerful tools and give the right people on your team the right level of access to get to that data and have a unified approach to data integration, overall management and monitoring of your pipelines, of your orchestration, a coherent and complete security approach. And all of this then empowers the downstream systems, downstream services, downstream audience. It's about not only bringing your data and working smartly with that data, but it's also about how do you effectively communicate the insights that are being derived, not only in reports, but also by injecting those insights into applications that your users are using on a daily basis. So if we dive a little bit deeper into Synapse, what we see then is some of the key pieces that are a part of this overall story. So on the top, you see the Synapse icon as the whole unified experience. At the bottom, you see the icon for Purview, right? With Azure Purview being the central data governance solution that provides you with a searchable data catalog so that all the data that you're bringing into your data lake is made available and searchable to your business analysts, your education analysts. And there's a lot of accompanying technologies. I won't go into all of them on this, in this brief talk, but what's key here is that there are really strong features across the tech stack that allow you to bring transactional data into this centralized analytical space and then give you this real-time or near real-time experience that doesn't affect your production applications. So that's really key, is having the ability to constantly be flowing these new data sets into a powerful analytics modern data estate so that you can leverage that data quickly. All right, so if you haven't seen Synapse Studio, just at a high level, this is what it looks like. And again, it gives you this one unified user experience backed by best practices and a Git repository so that everything your team is developing together is following a standard versioning process. And allowing you to be very rigorous in your deployment of pipelines and transformation scripts. So this is at a high level what it looks like. I'm gonna step now a little bit out of this talking about the Microsoft stack and talk a little bit more about the approach at a high level. And I'm super excited to be at Microsoft at this point in time, because there's this recognition within our culture that it's working directly with customers. That's what makes our approach special. At the end of the day, it's about empowering the ecosystem and building these innovations that are it's greater than the platforms themselves, these communities. And the approach then is to focus on trust, focus on integration that's open at every layer, focus on how do we empower the ecosystem to be successful, and effectively like commoditize the low-level plumbing so that the ecosystem can focus on the higher level value, right? And really drive that value point. So that's at the heart of all of this. And for open education analytics, this is an initiative that I've been focused on now for a couple of years, together with Maria Langworthy and our team. And we've really been working to build this bridge across two different areas, across the ecosystem itself, and as far as like having the right conversations with higher ed institutions, with our partners, and getting a better feel for what is needed in the real world. What kind of analytics are specifically seen as most valuable today, and how is our tech stack needing to be tweaked and adjusted and built on to better address those needs. So it's having those discussions within a community of practice. That's a big part of our open education analytics initiative. And then bringing what we're learning also back to product managers and developers and engineers within Microsoft to better inform the overall direction of the platform. But then also on the tech side, which is where I'm spend most of my time and my focus, it's an opportunity to see what's actually getting built in the field, right? What's being in the real world, in the trenches, and seeing the patterns that are emerging from the different dashboards and reports and learning models. It's about finding those patterns and then building into a shared repository layers of abstraction that can be reused out of those common patterns, those common themes. And so it's this iterative cycle of let's refine what's getting built out there and standardize and effectively commoditize that into the platform over time. Okay, so the Open Education Analytics website is a good starting place if you want more information about becoming a part of either a work group or community of practice. We also have a list of partners on the website that allow you to work with a partner if you want more hands-on kind of advice and guidance through the process of setting up a modern data estate. I'm gonna transition now and talk a little bit about the architecture on top of the stack as part of Open Education Analytics. And I know I'm going at a pretty fast pace. If there are any questions, I'm happy to take them. I am watching the chat as we go, so feel free to jump in with any questions along the way. Either come off mute and jump in, or if you want to put it in the chat, that's fine either way. So this picture, is similar to one I showed previously about Synapse, and the point of Open Education Analytics is leverage to the hilt all of the powerful data services in Azure, but put an education flavor, right, an education layer on top of that strong foundation, and make it more specific to the education industry. And this is P20W. It's not just higher ed. It's not just K-12, and it's also global in its nature. And there's a risk, at maybe coming at it at that kind of level of ambition about being spread too thin. But the point here is not for building a product per se. It's about facilitating the crowdsourcing of assets around the world in this space, and bringing those assets together to be reused. So this is at a high level the reference architecture, in the sense that it's the pillars are Synapse and Power BI, and then Open Education Analytics is a set of assets that build on those pillars to address these 5 key areas. Collecting data, ingesting that data into a usable, queryable format, analyzing that data and giving you the right tools to perform that analysis, being able to then publish data products, and then finally use those to inform your users. All right, if we peel back that layer and go a step deeper, it looks like this, where at the bottom, at the core, there's really 4 main areas, or 5 main areas actually, that make up the foundational tech stack. And so that's Synapse. It's the data lake storage itself, which is blob storage. It's Azure Purview for data governance, and then Azure Active Directory for all of the role-based access control. And then finally, Power BI to have that effective communication of the insights being derived. And then on top of this, OEA is broken up into these 4 areas, the foundation being the framework itself, which can be seen as an opinionated framework that by having some conventions to how you approach this, you're then able to create reusable pieces on top of that opinionated framework. And so those reusable pieces are cataloged in these different components: modules, schemas, and packages. And so all of this then works together to solve the age-old problem, and to lead you through your analytics journey, right, where you're able to be very successful in the basics of BI, but then move on into more advanced analytics. All right, so if we talk for a second about more of the details around what is contained within Open Education Analytics, this is depicting how things are structured in the GitHub repository. So within Synapse, right, we have the OEA framework itself, and that can be seen here on the left. We have a folder that's specific to the framework. And this provides you with a really simple setup script to get started in Azure. All you need is your own Azure subscription, and you get set up, quickly to get started. Part of that framework, it includes conventions such as what are the expectations around how you've structured your data lake, so that these components are able to be plugged into the framework. Right now, we're on version 0.6.1. We have version 0.7 coming later out this week. So, I should also make sure it's clear that this is not a released product per se. This is a set of utilities and best practices that are meant to be a strong accelerator, a strong starting place. But these assets themselves don't come with an SLA. This is more about the community contributing back, and us trying to facilitate the sharing of these different pieces. So the way this is structured is that you have a schema, and this could be a standardized schema, or it could be a schema that is just been found to be helpful in a given scenario, or a given use case. And so with that schema, you then use modules to hydrate that schema, and then have these overall packages that assemble multiple modules and potentially multiple schemas, and provide you with reports or machine learning models or other assets that give you this end-to-end a way of addressing a use case within your analytics. So a big part of the work then is having the ability to crowdsource these modules that address bringing in data from a lot of different data sources in the ecosystem. just getting the data in is often a challenge, right? And so having modules that have those pipelines as effectively a commodity, right? Having the ability to just extract from a system in volume and land it in such a way that it can be used is a very valuable proposition. When you get to schemas as the next phase, the idea with this lakehouse approach is, like Robert was mentioning in his earlier talk about the need for agility, right? The whole idea here is to be agile. It's approaching data engineering and analytics in an agile fashion so that you're not necessarily starting with a perfect schema, and there's an understanding that that's the case. You're starting with a lot of data and making it clear what data is available to your team. And then you're evolving the schema as you need to. You're taking, this iterative approach rather than a waterfall approach. So that's how modules and schemas and packages are structured. As I say, we're receiving contributions from the community and working to polish them and make them kind of curated within this repository. All right, I want to talk for a second about standards. When we talk about schemas, it would be ideal, wouldn't it, if we had the all-encompassing schema that kind of solved all of our problems. And the fact of the matter is that that doesn't exist, and we can't wait for it to just materialize. There are data standards, of course, that do exist that are very valuable, and so that's where available, that should be a good starting place. And then where it's not available, we should be quick at deriving what's necessary to fill the gaps. So standards, yes, but maybe what's a more solid foundation is a functioning ecosystem itself that's building value and then sharing common pieces so that we're not all reinventing the wheel. So that functioning ecosystem that has a vehicle for sharing and for deriving conventions, right? That's key. The next point is the modern tech, because while all of this may be age-old problems, the tech really facilitates and makes possible ways of rapidly iterating that we didn't have before. And so this lakehouse approach, as well as modern approaches to versioning and releasing, are really key. So that allows us then to get to this place of rapid iteration, where we can focus more on emergent design rather than kind of this design by committee, at a whiteboard or whatever, right? Like there's a place for designing at a whiteboard, and then there's a point where you've got to just build something and grow it over time, see what works and what doesn't. So that emergent design is key. When you have a lot of emergent design going on and a lot of really valuable pieces getting built, naturally what happens is that reusable assets and patterns start to emerge. And so then being able to capture those in a place that can be shared. And then you finally get to a place where now you can codify standards, right? Because solutions have been built, best practices have been derived. You can't necessarily start with the answer, right? You have to derive and codify the answer, and then you can solidify that. So that's the approach being taken here, is how do we as an ecosystem get better at iterating and creating a marketplace of ideas and schemas where you can have this real value competing in a marketplace, and then we can harden what's working. All right, so let's see, time-wise, we're doing all right. I've got 15 more minutes before we switch over. I want to talk a little bit deeper about some of the ways that we as an ecosystem can begin to adopt certain conventions, whether or not you choose to become a part of open education analytics, whether or not you choose to work with the Microsoft stack. There are conventions that as an ecosystem we can start settling on and better share even across stacks what's getting built. So this convention is starting to be pretty widely accepted. This idea that within your data lake, you really need to have three key areas: the bronze layer, the silver, and the gold. And the idea is that, as opposed to kind of old style data warehousing, where you are extracting data and then immediately doing a lot of transformations to try to get it into some hardened schema that's got, really strong constraints on it. Rather than doing that, which takes months or years, it's best to split out the challenge of collecting data from the challenge of doing something smart with it, right? Let's first clear that first hurdle, just collect the data. And so the bronze area is all about land data extracts in batch form, in whatever format the source system wants to, provide it in. So CSV or JSON or XML or whatever. And having that completed, once you have these pipelines that are sourcing the data in batches, you then are in complete control downstream of that, right? And so you're able to, architect the processes and orchestrate the processes to bring that data in. And as you need to, you can then even rework that, right? You can iterate on what you do with the data after that point. So the point here of bronze is just get the data in your hands in whatever format. Let's simplify that as much as possible. Just get the data in. From there, the next step, ingestion. Again, we want to try to separate the idea of doing a lot of transformations and mapping to a standard or mapping to some hardened schema. That's a large task, right? So here, ingestion is a more modest goal. Just get that batch data merged into one coherent representation and have it in a binary columnar format that's queryable, right? That's query ready. That alone is a big enough goal, right? If you can do that, and what's good is that a well-developed framework can automate these first two steps pretty effectively. If we as an industry, as an ecosystem, are sharing these extract pipelines that are pretty generic because they're not doing transformations, they're just extracting, right? We can catalog those and share those effectively, regardless of what, more or less, regardless of what tech stack you're using. Ingestion is the same kind of thing. If you're not doing a lot of transformations and mappings, if what you're doing is merging with what was ingested before, and you're writing to this Delta Lake format, that can be automated readily. I'm going to talk for a second about the Delta Lake format. If you're not familiar with Delta Lake or Spark, I recommend looking into those technologies. Those are foundational to this lakehouse approach. And the Delta Lake as a standard is built on top of Parquet. So the Parquet format is an Apache open source file format that is binary and columnar. So you get great benefits around performance and around compression, and its queryable status. But then Delta Lake adds to that, the ability to have ACID transactions. It effectively gives you a transaction log like Git does, so that you can have concurrent data services working with your data and maintain the integrity on that data. So Delta Lake is key, and Delta Lake also is an open source format that continues to grow and enjoy a lot of momentum. So what's key then here is that not only do you have bronze, silver, gold, but also that you adopt an approach of bring data in the raw, get it into a Delta Lake format, and then have this ability to use these lakehouse features. All right, so in stage 2, once you've ingested it and now it's in a query ready state, you've now effectively empowered your data engineering and data scientists, teams to work with that data effectively and to iterate over that data. So this is where you can then have all kinds of enrichments and refining and aggregation going on in a highly productive environment where you're either using Spark, if that's your level of familiarity, and you could be using PySpark, or you could be using Scala, or what have you. And so developing within this notebook, this interactive notebook, UI, it's just a really powerful approach to now being able to do something smart with the data. It didn't take months to figure out how that data should be represented. None of that. You're able to add additional resources, additional data sets quickly. That's all part of this approach. And so now this moment of refinement is a never-ending kind of iterative approach, where you're certainly getting better with what's getting built, but it's never really it's versioned, and you're never at an end state. You're always improving, and so that's what stage 2 is intended to facilitate. As insights then get identified, derived, you're then able to publish this in an optimized form to feed downstream assets, whether those are reports or dashboards or machine learning models. And so publishing out to a further denormalized star schema to empower these types of assets is this final step. And so you can think of it as data products that are getting published, right? That the team is using an agile process to develop data products that should undergo a similar versioning and release cycle. And so these data products then become very reliable, very mature over time as you grow them. All right. So let's talk then a little bit about what are the ways that we could effectively be better about standardizing across this lakehouse architecture. The first is the structure of the data lake itself, having this bronze, silver, gold. The second point is using Delta Lake for the lakehouse features. This is where that open and integrated across every layer comes into play. If we are using open standards with the data representation, then that really allows for competition when we're talking about what orchestration tech are we using, or what transformation tech are we using. The third point, use of metadata to auto-generate the data pipelines. A lot of the logic for collecting data can be contained within metadata, right? So when we talk about using a RESTful API to land JSON payloads into batches, a lot of that can be specified just by being able to list all the endpoints you have to hit and what URL are you going to, right? So you can really compress what's unique about a given situation into metadata and effectively have metadata that is being shared and have the pipelines be generated from that. So that's an area that we could be better sharing what's getting developed as an ecosystem. You can also have metadata that allows you to perform a lot of the transformations, automate a lot of the transformations. So let's say, for instance, you're landing a lot of JSON payloads in stage 1, and you need to flatten the JSON in various ways to really make it functional in stage 2. That first part of ingestion, perhaps you're not going to want to do a lot of transformations there, but you can automate the refinement of the flattening of that JSON. Another area that you can automate is if you have metadata that tells you what attributes are sensitive, you can then automate the pseudonymization of this data, right? So that you have the data written into different areas within stage 2, where you have sensitive data already masked, already hashed, and then you have general data that's more generally available. And then the ability, if you have the right access, the ability to then merge those as needed to give, you know, the sensitive data to those that need it in the right, you know, dashboard. So all that is contained within this idea of using metadata. The fourth point, standardizing schemas in the gold zone, and then fifth also in the silver zone. Everyone recognizes the power of having these standardized schemas in the sense that any assets built on them then become reusable, and that's great. What's challenging is that it proves to be a real challenge to get those schemas developed and have them be well adopted. And so, it's important to have this as a goal for us as an ecosystem, in my opinion, that we're constantly striving for, but at the same time, not allowing, excellent to be the enemy of good, right? Like we should not be in a holding pattern waiting for these schemas to be developed, and we should have an effective way to be evolving towards these schemas. So yes, let's have standards and let's keep growing those standards, but let's also, as an ecosystem, be very open to and very willing to build alongside those standards as needed, and then do the work of incorporating advancements into standards going forward. I believe that is my last slide. I'm happy again to address any questions. I'm a couple minutes early, so that's better than being a couple minutes late, Alicia. But if there are any questions, I'm happy to take them now. I'm also happy to take any follow-up later. You can reach me at gene.garcia@microsoft.com. And Alicia, I'm gonna tee you up next to take over from here if there are no questions that come in.
Thank you, Gene. That was fantastic. And Gene hasn't seen my slides, so he doesn't know what you all are in store for. But this perfectly dovetails into what I'd like to talk about today. So I love in-person presentations, and I'm so sad that I'm not physically in the same room as you all. But we have a small enough group that I thought we could get to know each other. And it's always interesting to hear kind of what everybody's working on and what's top of mind. So I'm going to go ahead and drop a couple of questions into the chat. And this is going to get us started to think about some of the ways that we're spending our time when we should be spending a little bit more time on the reporting side. Like, how much of that time are we spending collecting and aggregating and cleaning our data? And that's really going to put us into the mindset with some of the tools that are available for us to shortcut the amount of time that we're spending there. So let me go ahead and share my screen. And the questions I had dropped in the chat were, what department are you in? Are you in the business side of the house or the IT side of the house? And would you consider yourself to be a data steward? And if so, how much time, or if you are not a technical data steward, are you still spending time collecting your data and cleaning the data? And finally, do you trust your data? So today, I'd like to start by talking about how we can leverage tools to provide further business value with both data governance and master data management, as well as high performance compute capabilities within Azure. So we spoke earlier about OEA standards and data conformity. So how do we enforce data standards, and how do we wrangle data without data standards? Also, how do we enable our reporting systems to be responsive to changes in the data and empower every worker to be a data steward? As we supplement our operations with new technologies, our data footprint continuously grows. Now, this produces new So these are the challenges that data governance really helps us to address. Effective data governance equips us with both the processes and the tools to be responsive to the changes to data within our data estate. So I'd like to talk a little briefly about Microsoft Purview. And Microsoft Purview is integrated with our security tools and offers, and it provides unified data governance. So this helps establish processes that provide the business with full transparency. So starting with the Microsoft Purview data map, we can go ahead and capture metadata and stay up to date with built-in scanning and classification. The data catalog is going to help to understand the origin of your data through interactive data lineage using visualizations. And the Data Estate Insights dashboard is purpose-built for governance stakeholders. So the focus there is going to be on data management, compliance, and data use. So this application is going to provide actionable insights into the organization's data estate, catalog usage, adoption, and processes. So what this gives you is this gives you clarity into your user adoption. You know, it's great to have a process and to come together and discuss the plan of action. But, you know, change is a learning process. So how do we learn together to use data differently? And that is what data governance is. It's a set of processes for us to learn together collectively about different ways to use our data differently so that we can go ahead and be agile and adjust with the business. So this clarity into where the data is coming from and who has access to it by nature creates and reflects data ownership. So this transparency is going to go ahead and create an ease for compliance and reporting with your industry regulations. Now, Prophecy is an Azure PaaS MDM solution. So that's going to be a master data management. And we integrate very well with the Prophecy system that runs on Azure services and has a golden record matching algorithm. So the algorithm is going to go ahead and match, cleanse, deduplicate, and verify performance of millions of records. So within our institutions, when we're looking at the different places that we have student data and the different systems that we're providing reports to or pulling reporting data down from, it can be a challenge to have the compute and the resources to match these records up so that we can optimize reporting in a speedy way. So with the combination of Purview and Azure Purview and Prophecy, we can go ahead and push the master data model from Prophecy to Purview. We can go ahead and enrich the data entities there with ownership and glossary terms. And then we can go ahead and sync that information and enforce policies within the Prophecy system. So in a nutshell, the master data in Prophecy is validated, cleansed, and standardized using governance output from Azure Purview. So what does that do for us as far as data stewardship throughout the organization, and how does that affect the way we look at data? So at the end of the day, data governance enables and empowers our workers. They now have clear line of sight into what data is driving their metrics. and they have clear processes for data change management. What that means for us in education is we can go ahead and build complete 360 views around student data, and this can be based off of systems with standards, such as OEA standard compliant data, or data that we receive from outside external agencies, or even reference data. So some of the reference data is going to be demographic data. How do we associate bus route maps with the services that we're providing to our different students? And then, of course, faculty 360 views. So how do we go ahead and bump data about our students up against our faculty and staff? Now, another thing that I'd like to talk about today is how we can go ahead and leverage high performance compute. So within the education community, I do work with some of our academic medical research centers. And we do talk about, within the research environment, there's this whole ecosystem of different people who have different needs for data and different resources. A lot of this funding being tied to grants and the grant cycle. Now we have to talk about how do we securely process this data with resources that are aligned to the grant project. So when we're thinking about the resource project lifecycle, we're now in almost an agile infrastructure scenario. Now, some of the challenges that we face are the inability to have access to on-prem resources for analyzing some of these huge AI and machine learning workloads. And this is exactly a scenario where we can go ahead and scale up dynamically by using HPC workloads, where you're not scaling across machines. What you're doing is you're taking one workload and parallelizing a single job across virtual servers and physical servers. So when you're looking at the start of a grant project that may run 6 months to a year versus an IT operational need where it's an ongoing need that will run the life of however long the business is going to run, we can go ahead and use tagging and associate these resources and workloads specifically to grant work or departments performing this research, and they can have that dynamic access that scales when they need access to it. So we are seeing that with the ability to run and author Python and R notebooks in Azure, as well as running Jupyter notebooks as well, researchers are easily able to leverage existing code or build upon existing code by using Azure native resources. And with the addition of HPC, researchers also have the amazing abilities to bring more in-depth research projects to the cloud. And we are finishing just a little early, but I did want to share with you a couple of links to learn more information about OEA. And if you'd like to learn a little bit more about the capabilities of Microsoft Purview and Prophecy, as well as Azure for HPC. And I am looking in the chat, and I did want to open up the floor as far as, what are some of the things that you are seeing and are top of mind for this year? And if you had any feedback on either master data management, or if you had feedback on OEA.
I'll address one of the questions here. There's a comment about cleaning data being a journey. Vincent says, our team spends a significant amount of time validating data we are collecting as well as keeping it clean. Sometimes a challenge when multiple departments use the same data sets of the ERP. As long as data comes from the single source of truth, the data is trusted. So from a validation standpoint, I totally agree. This is an area too that is helpful to approach with an iterative kind of mindset, because where validation can become perhaps overzealous is, when it leads to loss of significant data because the validations are very stringent, and depending on what is being done, you want to be careful that sometimes not perfectly clean data is better than no data, right? And so depending on the use case, you may have more stringent or less stringent requirements on the validation being done. And so this is where it can be helpful to have multiple data sets that you have ever increasing levels of validation, and that way it serves the different use cases. This is an example too of how an older way of thinking is to not have duplicated data. And there's certainly you can certainly increase your administrative complexity by having duplicated data, but depending on if you're judicious about what data you're duplicating and for what reasons, you can also make it a lot more clear how things are structured. So I would say that if there's a reflexive tendency to just optimize for reduced data, and you never duplicate data, I'd say that's overly optimizing for the wrong thing. And so data validation often can be a little bit easier to address and to understand if you're willing to have duplicated data.
And that's a great point. And I see Billy's comment as well, and I think that definitely reflects that we all use data a little differently, and allowing for both a little bit of conformity and a little bit of personalization is really kind of the key to helping optimize systems.
All right. Well, thank you guys very, very much. Caden did put a link to a session feedback form. So if you can take a few moments to fill that out so we can learn from today's session. If you guys have any follow-up that you would like the presenters to follow up with you, please put the feedback in that form or reach out to me, stscholz@microsoft.com, and I would be more than happy to pass that along as well. Alicia and Jean, thank you very, very much for doing this. And the next session is an hour away. We're just about an hour and 5 minutes away because we're going to be breaking for lunch now. Thank you very much and have a great day. And I'm going to stop the recording.
Thank you.